In this special episode of the Denoise podcast, we're going to do a breakdown of NVIDIA's GTC Keynote. Let's get into it. All right, welcome. New location, Addy.
Yeah, this is
Thanks
great.
for stopping by. All right, so we got a special episode. The NVIDIA Keynote just happened this morning. We watched it. Let's do kind of a play-by-play summary, coming in at the angle of M&E, Media and Entertainment.
Yeah, sounds good. And we also saw the CES Keynote together.
Yeah.
So we'll talk about sort of the differences between the two.
Yeah, things we noticed that are different, things that are coming, and kind of what that means, and a summary too, so you don't have to spend 2 hours watching the keynote, which also had a couple live stream issues. Oh yeah, it cut out. The whole thing cut out at one point.
Oh really?
Yeah, the entire live stream.
Oh my gosh.
The first thing that stood out to me, and this was right in the intro, they had the garden area that they showed at the CES keynote that was talking about rendering and how it's being rendered in real-time ray tracing. And Jensen noted again that for every 1 pixel that was generated, 15 were rendered with AI.
For every pixel that's rendered, artificial intelligence predicts the other 15.
And I feel like I didn't check the notes, but I think in CES he said for every 1 pixel it was rendered, 8 pixels were generated. So I don't know if that's just a increase or a misspeak, or an increase in.
I think he's talking about DLSS.
Yeah.
So DLSS,
which they didn't talk about at all in this keynote.
Okay, yeah, I mean that was a big part of CES keynote. And we use DLSS a lot in virtual production because we're dealing with really large walls with large resolution, but we're limited by the amount of GPU and the power of Unreal Engine, if you will. So DLSS is a quick way for us to go from like a 2K render on a computer up to an 8K render, whatever that the wall needs. So in this case, without
having to process every single pixel.
Right.
Like so the computer figures out what the other pixel should be.
It's crazy. It's generatively filling in all of the details.
Friend James Blevins also been a big fan
of DLSS.
Yeah, and hyping it up and talking about like people need to pay attention to this.
Yeah, absolutely. He's right. DLSS is supposed to be way more computationally efficient than just rendering those extra pixels out. It also pairs well with denoisers. So denoisers and DLSS together means you just have to do less in real time.
Give it a noisy image, use AI to decipher and upscale what that final image should be.
That's it.
Which we have talked about here in past episodes.
Yep.
On denoised.
On denoised.
So that was the only kind of mention, and that just stood out to me because I don't know if it was just a mix of the numbers or if there was an improvement that they didn't really highlight in DLSS or how they're able to do real-time rendering. That was pretty much it for a lot of kind of M&E specific related stuff. Moving through sort of what the highlights were, he kind of did a recap of stuff he talked about at CES and sort of the development of AI, and that we're progressing to agentic AI agents, which we've talked about here on the podcast. And that the next step to that is physical AI and robotics AI, which we just talked about in the episode that went out today with
Perfect
DeepMind.
timing.
Yes, and DeepMind does come back to play a role at the very end.
Yeah, spoiler alert.
Yeah, spoiler alert. The next thing that he moved on to, which stood out a lot, is AI factories.
Yeah.
And this is a fancier word for data centers.
Now, this is a very big idea. Whereas in the past, we wrote the software and we ran it on computers, in the future, the computer is going to generate the tokens for the software. And so the computer has become a generator of tokens, not a retrieval of files. From retrieval-based computing to generative-based computing, from the old way of doing data centers to a new way of building these infrastructure, and I call them AI factories. They're AI factories because it has one job and one job only, generating these incredible tokens that we then reconstitute into music, into words, into videos, into research, into chemicals or proteins. We reconstitute it into all kinds of information of different types.
Yeah, I love the terminology here because Jensen and NVIDIA is really differentiating AI data center from the rest of the data centers by using a colloquial term that we all know and love and admire. Factories. Factories are the basis of revolutions. Industrial revolutions was all factories. So, in the same sense, the next era of human achievement is going to be AI factories. And I feel like that's the way he puts it.
Yeah. And one thing he did sort of frame the conversation at the beginning was how computing in the past was done from a retrieval computing model, and that the future he's trying to go to is generative computing model. So instead of retrieving the files or finding the things you're looking for, generating the things you're looking for. Yeah.
Generative AI fundamentally changed how computing is done. From a retrieval computing model, we now have a generative computing model. Whereas almost everything that we did in the past was about creating content in advance, storing multiple versions of it, and fetching whatever version we think is appropriate at the moment of use.
And that was sort of another theme that came up recurringly
Yeah.
in the keynote.
I mean, a lot of what Jensen said is so 30,000 feet up CEO speak, if you will, that I have a hard time following because I'm a concrete example kind of guy, and I always look for examples and cues and things like that. But again, this is in the realm of what do you mean you're going to generate the thing that I'm looking for?
So is it going to remain there after I finish it, or is it just like I just make it every time I need it?
Right.
Yeah. It's like, what does that look like?
What does that mean?
What is that? Yeah. Are we getting rid of buckets and files? But
it's his job to stay super ahead, 2, 3, 4 steps ahead of where we are.
And this keynote was a combo of like, here's things that are coming out that you probably already knew, and then here's our roadmap for the next few years.
Yeah.
And I feel like coming at this too, he's kind of got to be like, well, because this is coming into after DeepSeek comes out, and it's like, well, hey, do we need AI factories? Do we need these massive things anymore to like run these models or train these models?
And just to put it into context, DeepSeek did a lot of damage, not a lot of damage, but a significant amount of damage to NVIDIA stock prices.
Yeah.
And we did see the stock price dip during GTC, and it never really recovered from that initial dip.
Yeah. And I don't know what it's going to be like after people see it, but yeah, it's a bit of like, well, do we need these huge factories? Which when people build factories, they need to buy a lot of your chips.
A lot of hardware.
They need to buy as much of the chips. And I'd say there's still some cases of what he was talking about of where, yes, you would need that.
Yeah, I mean, there's no doubt that the world is already building quote unquote AI factories, right? Like if you look at any of the major tech companies like Meta or Google, they have data centers that are specifically doing AI computation at scale, quote unquote hyperscalers. So these are all the new terminology, at least for us here in M&E, that we're having to be accustomed to.
Yeah. And one of the examples that he did give, and he sort of spent a lot of time explaining the challenge for an AI company in that they are trying to generate millions of tokens, and tokens is sort of the backbone of generative AI, of like the things you make that turn into text or images or speech, and generating millions of tokens quickly. And sort of the battle.
The rate of generating the millions of tokens.
Right. And if that basically, he gave the example of the same issue that search has, where if you type a search query and you want like a response quickly, and so the longer it takes, maybe you get a better response, but it takes so long that people bounce from a user perspective.
Absolutely. I love what NVIDIA is doing with terminology and language around all of this. They're really putting into structure what we'll be saying just regularly over the next few years. So tokens, from what it sounds like, is like the currency of inference. So for example, for ChatGPT to generate one word of response, they need to generate 100 tokens in order to get to the end result of one word. So if you want to serve 100 customers and each customer needs like 1,000 tokens a second to be served, then you're making 100,000 tokens a second as a factory.
Yeah, and the factory is the backbone. He said they're AI factories because it has one job and one job only, generating these incredible tokens that we then reconstitute into music, into words, into videos, into research, into chemicals or proteins. And so you need the factories, you need their processors to make the foundation.
But I love the fact that Jensen is generalizing all of the different segments of AI down to tokens, which is like the US dollar, right? Like you can buy so many things with $1, and it all comes down to how much dollars you can earn so you can buy those things.
The solution to this was one of the big announcements, NVIDIA Dynamo.
NVIDIA Dynamo does all that. It is essentially the operating system of an AI factory.
Which is basically it seemed like a new operating system for AI factories.
Yeah. So the way Jensen put it was, right now, a AI factory has to ride on top of many layers of technology. You have to run VMware. VMware will then build virtual machines on the cloud, and that cloud then runs on the data center. The data centers use GPUs. So there's all these types of layers of technology that are working together. how he puts Dynamo is like that goes directly to the NVIDIA infrastructure, which encompasses their GPUs, their connections from GPU to one GPU to the next, one rack to the next.
And so basically like kind of turning your racks of GPUs into
One
a
single GPU.
massive GPU
Yeah.
that this language is able to communicate with that quickly. And also one of the other products they announced, integrated silicon photonics.
Yes.
Which it's a mouthful, and I think you better understand this than I did, but it was a way to speed up networking all of the different racks.
Yeah. So
be
right
more
now,
efficient.
if you put a data center together, it's going to have, let's say a giant data center has somewhere like 100 racks. And within 100 racks, you have 15 or 20 different servers. But they all have to interconnect. They all have to behave as one single organism. The way they do that is there is a fiber connection from one machine to the next, to the next, to the next. And then that rack is fiber connected to the next rack and down to a mainframe switch, if you will. What if you were to bypass all that and that fiber can connect directly to your GPU and then to the next GPU. So that's what this is. This is an optical interface right out of the silicon. I've never seen anything like this before.
Okay. That's wild. Yeah.
That's wild.
Still trying to wrap my head around that. But basically, faster, better way you can make these
More direct,
look like
higher
one
throughput.
giant GPU.
Yeah. You're no longer using copper or electricity to transport information. You're using light, which is going to have a higher throughput always. You can do terabytes of information per second on a fiber network. And then what's even cool about it is because it connects directly at a GPU level, stringing together tons of GPUs becomes easier than ever.
And now we're still talking data center scale, massive scale. These are like enterprise.
I just want to go back one step and just really look at the flavor and feel for this conference. CES felt more like NVIDIA is doing a lot of cool stuff, quote unquote.
It was obviously consumer focused at CES.
Yeah. So we got to see, more Omniverse stuff. We got to see tons of like consumer, like more autonomous car stuff.
Digits. They announced Digits with a personal
like
AI
actual
computer. Yeah, like a
computer.
little put on your desk kind of thing.
Yeah. This is their own conference. And because of that, they get to drive the message and what they want to share with the world. It felt like NVIDIA's, like most of the energy here was spent on data centers.
Yeah. And looking at last year's as well, this is a big enterprise focused data center conference.
Yeah. So clearly where they see their business or the bulk of their business is at the hands of hyperscalers who are going to build these massive AI factories. I mean, we're talking about 100 megawatt factories. That's like the output of a nuclear power plant.
Yeah.
Right.
And that's why you need
And
a
that's
nuclear
just
power
one of
plant to
them.
power these.
Yeah.
Yeah, that was mentioned in the right. That was a 100 megawatt factory using Blackwell chips, which can run or generate 12 billion tokens per second. Yeah.
Yeah.
I believe currently if it was on Hopper chips, the comparison was like 300 million tokens a second or something.
Which is still a lot.
Yeah.
But the argument Jensen's making is as your need for AI becomes more sophisticated, you'll need more tokens per user to generate that response or whatever, a video or...
And especially if we're going to go with his vision of a generative computing future.
Yeah, where
We need the factory.
instead
we
of
need AI
retrieving,
factories.
you're generating.
Yeah.
Yes.
So, this all ties into his prediction and his worldview. How much do you think that will be the case? How much do you think?
Good question.
Coming from our industry where we probably have some of the largest files, deal with the largest files of raw media, raw video, and kind of saying, oh, we're not going to do a retrieval system anymore. We're going to do a generative system.
Yeah, I don't know about that.
What does that even mean?
Well, maybe not for media and entertainment. Maybe it doesn't apply, but certainly for, social media, user-generated content, a lot of that could be just generated on the fly. I could see that.
Yeah, I mean, or if maybe it's a combo where you have like your source files, but you're generating your outputs, generating like your on the fly social media ads based on a collection of photos and videos. That
Again, I like
retrieving.
Both of us are super speculating here because he didn't give actual concrete examples of that.
No, and it was this is more.
But what I will say this is like
predictions.
the entire keynote was based around one theme to me is that you can just keep throwing hardware at the problem as the problem gets bigger and more complex.
For a lot of stuff.
So not only GPUs, but now you're throwing factories at the problem.
Or calling them factories. Data centers, which we've had for a while, but AI factories. Sort of on the flip side, one of the things they did call out too in one of their little pie charts of new features or code bases was 6G, Edge 6G.
But one of the areas that I'm super excited about is Edge. And today we announced today that Cisco, NVIDIA, T-Mobile, the largest telecommunications company in the world, Cerberus ODC, are going to build a full stack for radio networks here in the United States. And that's going to be the second stack. So that this current stack we're announcing today will put AI into the edge.
You've worked in 5G.
Yes.
Where does 6G go, and what does this potentially mean for AI? I'm assuming this is some sort of like edge AI functioning on your phone locally. You don't need an AI factory to like
it's
run a model.
Maybe we should ask ChatGPT, but it's when we were working on 5G, we were deploying 5G at Verizon. This was 2018 or so, a few years back. Verizon at the time was already moving on to 6G. So at that time, they were specifying what exactly 6G meant. Is it 1 terabyte a second download speed? Is it sub-millisecond latency? Is it edge computer that's always connected to your phone that does all the heavy lifting and your phone is just a thin client? So all of these things. So it's not clear to me what 6G means, but clearly we're past 5G and moving into a world where the interconnectivity needs are so great that we have to create a whole new set of architecture to accommodate it.
Interesting. The other thing, announcement and kind of big focus was on autonomous vehicles, self-driving vehicles, Cosmo, which you talked about in the last episode of their data set for driving and understanding the real world to create autonomous vehicles. And they announced a partnership with GM where GM's going to be using the NVIDIA chips to power their self-driving fleet.
Yeah, that's
practical use case.
Pretty dope.
Yeah.
First of all,
and we talked about how this has to be something too that has to happen in real time.
Yeah,
like obviously because
we literally just covered this last episode. Yeah, self-driving vehicles is already here. I'm in Santa Monica, and I just literally saw 10 Waymo cars just driving around here. The question is, how do we get this to scale? How do we get the cars to be more autonomous? So if a car is offline, it could still do what it needs to do and just do inference locally on device.
Right. Yeah. So drive in the canyon areas here, and you're like, you lose cell phone reception. You're like, I can't pull up my maps anymore. How do I get out of here? You're driving the car, not a big deal. But if your car is reliant on computing, AI to figure it out,
and then like you and I were saying, it has to compute in real time at hundreds of frames a second because a car is moving so fast. Right. So even like a 30 frames per second camera, whatever milliseconds at whatever speed, that's the chunk of distance you're covering. Right. So it's the requirements are enormous. So I think NVIDIA is right to be in this business because it's also such a massive business. It's trillions and trillions of dollars in people reinvesting in their vehicles, buying a car that could drive itself over the next 10, 15 years.
Yeah. Talking about something that will revolutionize transportation.
Right.
So I'm curious to see where that goes with GM and kind of how they release that in the cars.
Yeah. I just quickly did a ChatGPT on 6G, and I was right. So 6G is supposedly 1 terabytes per second, which is 100 times faster than 5G.
Okay. Lower latency?
Expected to be under 1 millisecond. Yeah, so I was right about that too. Okay. So 5G is anywhere between, I believe, it's a single digit. So 2
What does that even look like when they're like, we got to update to 6G? Is that more antennas? Is that different antennas? What does that
Completely different infrastructure. So when we went from 4G to 5G, the 4G stuff could not be used.
So they had to go and do they repurpose existing antennas? Do they build new ones? Do you have to have more? How does that work?
The 4G antennas remain because your phone can interchange between. It has 2 antennas. But the way 5G coverage worked, and I think I went over this on one of the podcasts, is you just need to blanket more cell towers because it's connecting at different frequencies at the same time, whereas 4G is like a single direct link. Imagine 5G is like 10, 15 different links at the same time. So in an area like, this area we're in, one 4G tower will cover like 10, 15 city blocks, but you'll need one or 2 5G towers per block or something insane to cover it correctly.
Okay.
Yeah.
All right.
So I would imagine
So
6G
you
is
think
even crazier.
Even more towers for 6G?
Maybe.
Okay. Possible. All right.
Possible. Yeah.
I'm trying to scrape every M&E thing that was sort of covered. They always have these really cool animations flying around through their San Jose headquarters. And so they had these 3D animations moving around the office. And then he did mention like these were all Gaussian splats.
Gaussian splats, just in case.
So they scanned the entire building and were doing these animations with Gaussian splats that they turned into animations. Yeah.
It's cool. I mean,
I'm scraping for M&E stuff here.
Well, Omniverse is everywhere. Omniverse is now the primary engine to train all of the autonomous vehicle models. And if you combine Omniverse with Cosmos, which is their world model, you can pretty much simulate any robot in that environment. Or rather, you can have a robot train in that synthetic environment.
Okay, right. Okay. Yeah, there's a ton of use. Omniverse is very omni. It's very big. Yeah, I've seen that. We've seen with self-driving vehicles. We've seen a lot with like factory planning and building out your factory and running simulations. They also talked about building out your AI factory at a data center and running tests and simulations, which is a new feature use case that they focused a good amount of time on.
It's like, how do you actually design and build this 100 megawatt insane AI factory? Well, NVIDIA has a tool for that.
Yeah, we have a tool. We have a tool for
They're
you. They're
basically making it frictionless for you to spend $1 billion on a factory.
As far as new chips and updates, they did announce the new Blackwell Ultra NVL 72, which is bigger, better Blackwell chip coming out later this year. And then they laid out the framework for the next generation of chips, which they're going to call the Rubin Ultra, named after the person who discovered dark matter. Yeah. And that's going to, they said, would come out in the second half of 2027.
Wow.
So that's a big announcement for also like...
That's hella early.
Laying out, announcing this now and being like, it's going to come out about 2 years from now.
Right.
Yeah. I think they just want to give people this roadmap of like, there is bigger and better things coming.
I think it's also like a stock price play. I mean, look, the biggest product for any public company is their share price. So the entire conference is just meant to build confidence in investors. Yeah,
and especially when it's like they're riding so high, but everything's tied to a quarter, and it's like, well, what's next? What's bigger and better? And it's like, oh, we like got a million chips everywhere, and like training AI stuff. It's like, it's not like this stuff isn't happening fast enough. We need bigger and better. The other hardware thing was DGX stations. And so these are ranging from sort of like personal desktop size AI stations, basically AI workstations for AI training and data science that they're going to partner up with all the major computer manufacturers and sell versions of these DGX stations. I have no idea what the pricing is, but it seems like much more higher end computer to do.
Yeah.
Have you seen?
Yeah, we almost bought a DGX station 6-7 years ago when we were doing heavy Unreal work. At the time, I think it was like 4 or maybe 8 GPUs in a single box. They were retailing for $100,000 or so.
Okay. Yeah, I think, I don't know if it was a max or just what the average is, 784 gigabytes unified memory.
That's so important for AI stuff, the unified memory, as I'm finding out doing a lot of local stuff on my computer.
And reading more into what we talked about, the updates to the Mac Studio, that was something that also...
512 gigabytes.
Unified. That people were very impressed and were able to run.
Yeah, when a memory is unified, it's shared across the CPU and the GPU, I think. So there is no sort of transfer between the two.
What would you use the DGX? I mean, aside from, like, was that use case, let's just get a souped up station so we could run Unreal? Is that better than just doing a build out yourself? Like, what are the use cases for?
What I would do or what NVIDIA envisions?
Both.
So for me, it's just running a really fancy version of Comfy UI and doing a lot of local inference, local, video generation, style transfers, things like that. As a creative technologist, just running AI locally. I think how NVIDIA envisions it is any kind of professional work that you do, whether you're an accountant, whether you're a software programmer, whether you're a content creator, you're going to be using AI for it. And you need a different type of compute infrastructure for the next generation of tools
than what we've traditionally had.
Yes.
Of a CPU, GPU.
If you ask NVIDIA, they'll say you need DGX for every type of professional work. That's just my guess.
I'm curious to I'm curious to kind of see where the heavy VFX or where the kind of M&E applications are of getting a souped up computer like this. And then they touched on robotics, Omniverse, brought that up again.
Physical AI and robotics are moving so fast. Everybody pay attention to this space. This could very well likely be the largest industry of all.
Cosmos, which is their real world kind of data set of car driving. And understanding the 3D world.
It's the closest thing we have to a world simulation. So it takes into account things like air, water, physics-based collisions, materials of different types. I'm sure steel, bricks, wood, what have you. The more you put onto the Cosmos model, the heavier it gets, and the more computationally expensive it is to simulate it.
And lastly, big finale.
And so today we're announcing something really, really special. It is a partnership of 3 companies: DeepMind, Disney Research, and NVIDIA, and we call it Newton.
And then he brought out the BDX droid robot from Star Wars that we just talked about on the last podcast, and how we had seen it in some Imagineering videos and the whole training.
That robot's gone viral, dude.
Yeah, I mean, it's extremely cute, and then it's going to go even more viral after this because it like kept talking and beeping to him. I did notice the robot had a mic pack taped to its back that kind of
Why do you think that is?
So they could pick up the beeps and the noises and stuff. Yeah, yeah. So it was it was a very cute interaction with the robot and Jensen. It didn't go into much about what Newton is or what this partnership means. The only thing he did mention was that the droid had 2 NVIDIA computers inside it.
Just so you know, Blue has 2 computers, 2 NVIDIA computers inside.
Didn't say anything else.
It goes back to your question of why do you need DGX? Because when you're doing local inference, you absolutely need a ton of hardware to compute it in real time. And we covered this literally on the last episode. It's like, the reasons robots are back into the spotlight now is because we're pretty close to having real-time AI systems, if not already, and stuff that can truly be autonomous. You don't have to program it. It'll just figure out the world. And so that plays right into this Newton partnership.
Figure out the world. If it has the chips on it, they could also process it.
It has Cosmos loaded on it.
Real time. Yeah,
right.
And something that's small enough it could fit in this pretty small robot.
Yeah, and one of the words that you'll hear a lot is distilled model. What that means is taking like a big, heavyweight foundational model, essentially making a lightweight version of it, a travel pack, if you will, that can then run on limited hardware of a robot.
Yeah, that was pretty much the highlights. Groot N1, which was their foundational humanoid robot data set, they're open sourcing it. So I guess the idea there is to make it easier to use.
How do you open source a robot?
I think it's the training language or model.
Okay, sure.
Yeah, from highlight of knowledge from the keynote.
But I want to see the DeepMind humanoid, Tesla humanoid, NVIDIA humanoid, all like just battle it out. Wouldn't that be cool?
Through an actual battle or through a challenge?
Through a mind game.
Through a series like an ops. I want to see like...
How about they play blackjack together?
Or like Ninja Warrior.
Yeah.
But with the robots.
With an obstacle course. Absolutely. What were your thoughts on the whole conference? How did you feel? And what did it feel like that NVIDIA was driving towards?
Not being someone who is opening billion-dollar data centers. Felt a bit above my head. But yeah, I didn't feel like there was as many... wow moments. There wasn't even, I mean, I get what this keynote is targeting. It's not targeting. I was thinking there might be some more even gaming related stuff, which for M&E and for filmmaking, we adapt a lot of things from the gaming world, obviously with Unreal Engine and beyond that. So yeah, I was wishing there was a little bit more there, even if for anything on real-time ray tracing.
Yeah.
But definitely the end, focusing on robotics, focusing on Newton. I wish I knew a bit more about what Newton is.
Yeah.
That was exciting. And it's kind of sad in a way where it's like, well, yeah, they're going to just be making bigger and better chips. Like, okay, what else is new? But when we step back and think about it, it's like the things they're building are just absolutely insane.
It's insane.
And we were talking when we were watching it, just like all of the areas and fields and everything, where it's not just they're building the chips, but they're building the hardware to manage the data centers, and they're building the things to optimize the data centers itself, and just so many things. And then so many industries when they just display the board of like, healthcare,
like quantum physics and weather prediction, and chemistry.
Yeah. everything.
I don't know how Jensen sleeps at night, because we obsess over one.
I'm going to find out that he really is a robot. There's like five of him.
He is Newton.
Yeah.
Yeah. Look, there's no doubt that NVIDIA is clearly like leaps ahead of other companies as far as AI innovation goes. I think they really are pulling the world into a direction that they want. My only note here is, does the world need multiple 100-megawatt data centers or AI factories? Is that really necessary? Do we really need to burn that much energy to get to the next revolution, right, of the next level of technology?
I should note too, one of the things they talked about or highlighted, and I don't have the specific numbers, but like with the improved chips that are coming, like the new Blackwell and like the Rubin down the line, that part of the gist of them is they can do more, and they can do more running off less power. So, it seems like, yes, they're aware that these things are crushing energy and other issues come
But do you know the LED light paradox?
No, what is
supposedly when we went from incandescent light to, for a second there, the compact fluorescent, and now to LED lights, everybody, all the leaders around the world, and especially energy, scientists on the energy side, thought that we would consume less energy, just because it's like incredibly more efficient. Like 100-watt light is now 5 watts to run, right?
Is this now we leave them all on all the time?
That's it.
Yeah.
So it's like, I'm not going to turn that off. That's like
the exact same thing happened with the plastic bag ban here in California.
Oh, what happened?
The same exact thing. They ban plastic bags here. They charge you 10 cents for a bag. But if you ever shop in California and you do buy a bag, usually the plastic bags are like a very nice, like thick, kind of heavy duty plastic. So you feel like you're getting your 10 cents worth.
Yeah.
And so most people are like not bringing it didn't change the behavior to like bring your own bags. That was the intent. They don't bring their own bags. And they're just like, I'll pay the 10 cents. These bags use way more plastic than the cheapy, like the flimsy bags that you get for free. So now people are just paying for the bags. So they're using the same amount of bags, but now these bags use more plastic because they're thicker.
So now you're throwing away way more plastic.
So now, and they're not reusing them.
Yeah.
Basically, no behavior has changed. It's just became like a tax fee for shopping, and the bags are using more plastic.
That's what I'm saying. Yeah. That's what I'm saying. So even if we get to a world where we're doing way more GPU computation on a much smaller piece of energy, we're going to consume way more energy because we're just going to have more complex models be possible.
Right.
Yeah. So I think
what is the limit?
Well, AI computation.
Like the entire world is a digital twin. We have a multiverse of digital twins in AI factories, and we could just...
Ultimately, it's the Matrix, right? It's like a complete simulation of everything in our world.
We know how they powered their robots, their computers.
I don't know if it was the most efficient version of it, but okay. That's a great way to end this episode.
Yeah, we'll end it there. All right. Well, thanks, everyone, for joining us on the special episode. Links for everything that we talked about, which is the keynote and other press releases and stuff, we'll put on the website, denoisepodcast.com.
And we'll see you on the next regular episode from our regular studio.
Thanks, everyone. Bye.